Welcome to the Unreally Impressive Coder, where we transform aspiring engineers into tech giants one tutorial at a time. Join me as we dive deep into the world of FAANG interviews, demystifying the process and giving you the edge you need. Together we'll conquer data structures and algorithms, ensuring you have the skills to tackle any challenge thrown your way. We'll also explore competitive programming techniques, sharpening your problem-solving abilities and preparing you for coding competitions. In addition, you'll learn essential programming languages through engaging tutorials that cater to all skill levels.
Welcome to this video. In this video, we're going to solve this coding interview question, merge to sorted list. This is a popular coding interview question. This problem states that you are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists in one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. For examples, if you are given these two linked lists 1 to 4 and 1 to 1 3 4, we have to merge these two linked lists. The merged linked list must be sorted. This is the merged linked list. We cannot recreate the node. We have to solve this problem by manipulating the pointer. So for this given inputs, we have to return this linked list 1 1 2 3 4 4. If we're given empty linked list, we have to return empty. And if we are given this linked list, one linked list is empty and the second linked list contains just one node, so we have to return just one node. So this is the problem. Now let's see how to solve this problem. Now let's talk about how to solve this problem. Let's assume we're given a linked list 1 5 7 9, then null. This is our first linked list, and our second linked list is 2 3 5 6, then null. Let's assume we're given these two linked lists. This is our linked list 1. We can say list 1. This is our list 2. Now how we can merge these two linked lists such that the merged linked list also sorted in ascending order? The naive solution, we can use a mean heap data structure. In the mean heap data structure, we will store all the nodes for list 1 and list 2. Then we will just remove the top nodes and we will just add them one by one. But mean heap data structures will take for insertion, it will take a log n time complexity, where n is the length of the this linked list plus this linked list. So here n is actually it should be log of m plus n, and we have to do this m plus n times. So this algorithm will take this time complexity m plus n times log m plus n, and it will take space complexity m plus n. This is not efficient. If we came up with these solutions, a recruiter will not be happy with this solution. Let's see the efficient solution. The efficient solution, we're going to solve this problem in O of m plus n time complexity. Let's see how to solve this problem in O of m plus n time complexity, and it will take constant space. We're going to use two pointer. First, we're going to create a head. Let's call it our fake head, or we can just call it new head. So let's call a new head and let's create a node with any value you want. Okay, and we will initialize current pointer right here. So current pointer. This is our new head. This is our fake head, we can say. This is not the real head, this is the fake head. Let's call it new head. And here we'll use two pointer P1 pointer will point to the first node of list 1 and P2 pointer will point to the first node of our list 2. Now we're going to check the value of P1 pointer and P2 pointer. The value here is 1. We'll take the minimum. So minimum is 1. So let's take this node and we're going to add it here to the next of current. Now what I'm going to do, I'm going to move this current to this node now. So this is current. And since we have taken the value from this pointer, so we're going to move it to the next. It will point right here. Now we're going to check the value. We see the value we have here at P2 pointer is minimum. So let's take this node and let's add it to the next of current. So let's add here. Let's move current to the next. So current will point here. Since you have taken value from this pointer, so we're going to move this pointer to the next. Now what we're going to do, we're going to check the value of 2 pointer. 3 is minimum. So let's take this node. Let's add to the next of our current. So here we're going to add this node 3. So let's add here. And let's move current to the next. So current will point here. Since you have taken value from this node, we have taken this node. So let's move P2 right here. Now we see that P1 and P2 points to the same nodes. Now we can take the value from this second linked list, from P2 pointer or from P1 pointer. Let's take from P2 pointer. If we take value from P1 pointer, that's completely fine. You have to choose the value. If we find out 2 nodes are the same in the future, we have to follow the pattern. I'm going to take from P2. So let's add here 5. Let's move current to the next. Current will point here. And we have taken this value from here, so P2 will point here. Now we say that the value at P1 pointer is minimum. So let's take from P1. So let's add here 5. Let's move current to the next. Current will point here. So we have taken the nodes from P1 pointer, so P1 pointer will point here. Now we see that we have the minimum value at P2 pointer. So let's take from P2 pointer, which is 6. Let's move current to the next. So current will point here. Since you have taken from here, we have to move to the next. Now we saw that P2 pointer points to null. If we find out P1 pointer or P2 pointer points to null, we will just stop. And what we will do, if the P2 pointer points to null, we will assign the P1 pointer, the node where P1 pointer points to the next of current, which is 7. So here, and 7 is connected to 9. So we have just connected something like this, and 7 is connected to 9, 9 is connected to null. We are done. So we have merged these 2 linked lists. At this point, we are just assigning this portion. We know that this is sorted. Since this part is sorted, so if we add to the next, the rest part will be in sorted order. Since the 2 given linked lists are in sorted order, this is our algorithm. This algorithm will take for the worst case O of m plus n time complexity, where m is the length of the first linked list and n is the length of the second linked list. This solution will take space complexity O of 1. We're just using here a couple of pointers. So it will take constant space complexity. We're not using any additional space. We're just manipulating the pointer. We're not creating the new nodes. So it will take O of 1 space complexity. I hope you've understood this algorithm. Now let's implement this algorithm using Java programming language. Now let's implement our algorithm. First, we're going to create fake head, or we can call it new head. So let's create it. List node. The type is list node. New head equals to new list node. We can use any value. Let's use your -1. You can use 0, 1, whatever you want. Doesn't matter. This is our fake head. I'm just calling it new head. Now let's create here 3 pointers. List node P1. P1 will point to the head of our list 1, our linked list 1. So list 1. P2 will point to the head of list 2, and current will point to the new head, or to the fake head. Now here we're going to use while loop while P1 is not equals to null and P2 is not equals to null. If P1 and P2 is not equals to null, we're going to check the value. If P1.val is less than P2.val, then we will take the value from the node where P1 pointer points to. So current dot next, we're going to add it to the next of our fake it where current is pointing. So current dot next equals to P1. Now we have to move P1 to the next, since we have taken the value from P1, and we have to move the current to the next. So current equals to current dot next. Let's use it right here. We can use right below this line. It's okay, no problem. Else, if this is not the case, if this condition is false, it means that P2, the value at P2 is greater than or equals to P1 dot the value of P1. So in that case, we will take the value from P2 pointer. So current dot next equals to P2. We have to move current to the next. So current dot next, and we have to move P2 to the P2 dot next. This is our while loop. If we find out P1 is null, if we find out P1 points to null, then what we're gonna do, we're gonna just add the current dot next. Current dot next equals to P2. Here we can check another conditions. Actually, we don't need to check this condition, something like this, P2 dot null. If P2 is not equals to null, we can check this condition, or we can just leave it, no problem. If P2 is null, then current dot next will points to null. We can have something like this. If P2 equals to null, here we can just connect P2 current dot next equals to P1. Here also you can check these conditions. P1 is not equals to null. We don't need it. We can check it, no problem. So this is our algorithm actually. So this is our fake head. Our head is located to the next of this pointer new head. So we will just return our new head dot next. So this is our algorithm. This algorithm will take of m plus n time complexity, and it will take a space complexity of 1 constant. Now let's run this code. Let's run this code. Accept it. Let's submit it. We have successfully solved this problem. I hope you've understood this video explanation. If you have any question, or if you have an issue understanding this video explanation, post your question on the Q&A forum. Thanks for watching this video.